So today we learned about one type of experimental design called a completely randomized design. And there are a lot of things that need to happen to make an experiment go right. So we're going to take a little bit of time today to examine what can go wrong in an experiment. So a randomized comparative experiment, meaning an experiment with a randomized design that compares multiple treatments, depends on our ability to treat all the subjects the same in every way except for the actual treatments being compared. So good experiments require really careful attention to detail to really ensure that all subjects are treated identically. So let's look at an example of this. If some subjects in a medical experiment take a pill each day and a control group takes no pill, the subjects are not treated identically, right? One group is taking a pill and one group is not. So the way that we can treat these two groups identically is to have them both take a pill every day. However, one pill is going to contain aspirin or ibuprofen or vitamins, whatever you want them to take, and the other pill is going to take a placebo, what's known as a placebo. And many patients respond favorably to any kind of treatment, even a placebo, maybe because they trust the doctor, maybe because it's all in their head. This response to what we call a dummy treatment is what's known as the placebo effect. So an example of the placebo effect that we see all the time is when a parent kisses a child's boo-boo, right? The kid feels better when their parent kisses their injury. Even though the kiss has no kind of treatment in it, it makes the child feel better. The strength of the placebo effect is really, really strong. In many medical studies, it actually turns out that the placebo effect has a really significant impact on the way that patients feel. It won't be as impactful as the treatment necessarily, but it can really positively impact people and make people get better in medical situations. So because the placebo effect is so strong, it would be silly to tell subjects in a medical experiment whether they're receiving a drug or just a placebo. Knowing that they're getting just a placebo might actually weaken the placebo effect and bias the experiment in favor of the other treatment, meaning it would make the other treatment look better than it actually is. So not only do we not want to tell the patient or the subject about this, we also don't want to tell doctors and medical personnel what treatment each subject receives. This is only in the context of a study, right? Not when you go to the hospital, somebody knows what they're giving you. I'm only talking about in a study to see if a new drug works, let's say. So if the doctor knows that a subject is getting just a placebo, they may expect less from that patient than if they know the subject is receiving some promising new drug. So doctors' expectations change how they interact with patients and even the way they diagnose the patient's condition. So whenever possible, you want experiments with human subjects to be run double-blind, what's known as double-blind. And in a double-blind experiment, neither the subjects nor the people who interact with them to measure the response know which treatment a subject received. So the idea of a double-blind design is pretty simple. So until the experiment ends and the results are in, only the study's statistician, the person running the study, knows for sure which treatment a subject is receiving. There are some scenarios, however, where you can't carry out the experiment in a double-blind manner. So let's say researchers are comparing the effects of exercise and dieting on weight loss. The subjects are going to know which treatment they have, exercise or dieting. So this type of experiment can still be what's known as single-blind if the individuals who are interacting with the subjects and measuring the response don't know who's dieting and who's exercising. In other single-blind experiments, the subjects don't know which treatment they're receiving, but the people interacting with them do. In an experiment, researchers usually hope to see a difference in responses that are so large that they were unlikely just to happen because of chance variation. So when I talk about difference in responses, I'm talking about the way that subjects respond to different treatments. So we want to see responses to treatments that are so large that they are unlikely just to happen by chance. If that's the case, right? If results were unlikely to happen just by chance, then they are statistically significant. Don't worry too much about applying that word. For now, all you need to know is that if a result was unlikely to occur by chance, then it is statistically significant. Okay? So if we know that a strong association between variables does not imply causation. However, a statistically significant association in data from a well-designed experiment does imply causation. We're going to talk more about that later.